I am 104 years old, and leafy greens are not a food group. They are the most sophisticated biochemical pharmacy the human body has ever had access to, and almost no one understands what they are actually doing inside you. Most people think of leafy greens as nutrition, vitamins, fiber, the thing your doctor tells you to eat more of, but that framing misses the entire point. Leafy greens are not just delivering nutrients to a passive body, they're actively communicating with your immune system, your gut microbiome, your mitochondria, your gene expression. They are not food, they are signals. And when those signals stop arriving, the body does not just lose nutrients, it loses instructions. It loses the directions it needs to maintain itself, repair itself, and defend itself. That distinction changes everything. Inflammation is where this becomes critical. Everyone has heard the word. Chronic inflammation, the root of disease. But here's what most people miss. Inflammation is not the enemy. Inflammation is a process. It is your body's response to threat, infection, injury, toxin, stress. The problem is not that inflammation exists. The problem is that it does not turn off. And leafy greens, at their deepest level, are among the most powerful off switches ever studied in nutritional science. The mechanism begins with something called NF-κB, nuclear factor kappa B. It is a protein complex that sits inside almost every cell in your body and acts as a master switch for the inflammatory response. When your body detects a threat, NF-κB activates, genes get switched on, inflammatory cytokines get released, and the cascade begins. This is appropriate. This is healthy. But in modern humans, NF-κB is being triggered constantly by processed food, by chronic stress, by environmental toxins, by poor sleep, and it never fully quiets down. The result is a low-grade inflammatory fire that burns for decades and slowly destroys tissue, disrupts hormones, damages the cardiovascular system, and accelerates every disease process we associate with aging. And here's what most people miss. Specific compounds in leafy greens directly suppress NF-κB activity, not by blocking it permanently, that would be dangerous, but by modulating it, calming it, returning it to baseline after activation. This is not folklore, this is molecular biology. Compounds like sulforaphane and cruciferous greens, camphorol in kale and spinach, and quercetin found across multiple leafy varieties have been shown in repeated studies to inhibit NF-κB signaling, reduce cytokine production, and lower measurable inflammatory markers in human tissue. These are not subtle effects. In studies involving C-reactive protein, one of the most reliable blood markers for systemic inflammation, regular consumption of dark leafy greens has produced measurable reductions within weeks. But it goes even deeper than that, because the real power of leafy greens is not in any single compound. It is in the density and diversity of phytonutrients working together in a way that isolated supplements can never replicate. A supplement gives you one molecule. A leaf gives you thousands, in ratios and combinations that evolved over hundreds of millions of years in the context of a body exactly like yours. The synergy is not a bonus feature. It is the entire point. When researchers isolate individual polyphenols and test them alone, the effects are often modest. When they test the whole food, the effects multiply. That is not a coincidence. That is coevolution speaking. Take spinach. Most people think of iron, but the real story of spinach is its extraordinary concentration of thylakoids, the membrane structures inside chloroplasts where photosynthesis happens. Thylakoids, when consumed, act as powerful appetite regulators by slowing fat digestion and dramatically increasing the release of satiety hormones, particularly GLP-1. The same hormonal pathway that billion-dollar pharmaceutical drugs now try to mimic artificially. Spinach was doing this the whole time. But beyond appetite, thylakoids also carry chlorophyll. And chlorophyll, in the gut environment, binds to certain carcinogens and mutagenic compounds, forming complexes that the body can excrete rather than absorb. The leaf is not just feeding you, it is actively neutralizing threats before they reach your bloodstream. Now move to kale, and you enter a different biochemical world. Kale is a cruciferous vegetable, and cruciferous vegetables contain glucosinolates, sulfur-containing compounds that, when you chew or chop the leaf, come into contact with an enzyme called myrosinase and convert into isothiocyanates, the most studied of which is sulforaphane. Sulforaphane activates a transcription factor called NRF2, and NRF2 is extraordinary. When NRF2 is activated, it travels to the nucleus of your cells and switches on over 200 protective genes. Genes that produce antioxidant enzymes, detoxification proteins, anti-inflammatory molecules, and proteins that help repair damaged DNA. One compound triggering the expression of 200 protective genes. This is not a supplement effect. This is an epigenetic event. And it happens every time you eat kale and chew it properly. Here is something most people have never been told about kale and the other cruciferous greens. Cooking matters enormously. The enzyme myrosinase is heat sensitive. When you boil kale, you destroy myrosinase before it can convert glucosinolates into sulforaphane. You lose the most critical part of the biochemical reaction. But the gut microbiome also contains its own myrosinase-producing bacteria, so some conversion still happens. The practical solution is to chop or massage raw kale and let it sit for a few minutes before cooking. This gives myrosinase time to do its work before heat destroys it. Or eat it raw, or lightly steam rather than boil. The way you prepare the leaf changes its molecular activity in your body. That is not cooking advice. That is biochemistry. Move deeper into the world of leafy greens, and you arrive at something that most people have completely overlooked: the gut inflammation axis. The gut lining is a single cell layer thick, one cell. Between the bacterial world of the gut and the bloodstream of the body, there is a barrier so thin it is almost incomprehensible. And when that barrier is compromised, we awake to which modern diets, antibiotics, stress, and alcohol do constantly, bacterial fragments called lipopolysaccharides leak through into the bloodstream and trigger systemic inflammatory responses throughout the entire body. This is called intestinal permeability, and it is one of the primary drivers of chronic inflammation in modern humans. Leafy greens repair this. Specifically, they feed the bacteria that produce short-chain fatty acids, particularly butyrate, which is the primary fuel source for the cells lining the colon and the critical signal that tells those cells to maintain tight junction proteins, the molecular velcro that holds the gut barrier together. Without enough butyrate, tight junctions loosen, the barrier degrades, inflammation rises. With consistent fiber and polyphenol input from leafy greens, butyrate-producing bacteria thrive, tight junctions remain strong, and the gut barrier holds. The leafy green is not directly touching the gut wall. It is feeding the microbiome that maintains the wall. It is working 2 steps removed in a system of biological intelligence that we are only beginning to map. And here is the real hidden layer, the connection between the gut microbiome and the immune system. Approximately 70% of the immune system is located in the gut. The bacteria in your gut are not passengers. They are active trainers of your immune cells, teaching them what to attack and what to tolerate. A disrupted microbiome produces immune cells that are chronically dysregulated, overreacting to things they should ignore and sometimes failing to respond to things they should attack. Autoimmune conditions, allergies, even the immune surveillance failure that allows certain cancers to escape detection, all of these are connected to microbiome disruption. And leafy greens, through their fiber, their polyphenols, their prebiotic compounds, are among the most powerful microbiome restoration tools available to a human being eating real food. But the depth continues, because leafy greens also work directly at the level of the mitochondria, the energy-producing organelles inside your cells and the structures most damaged by chronic oxidative stress. Mitochondrial dysfunction is now understood to be a central feature of aging, neurodegeneration, cardiovascular disease, and metabolic disorders. When mitochondria are damaged, they produce more reactive oxygen species, which causes more damage, which produces more reactive oxygen species, a self-amplifying spiral of cellular decline. The polyphenols in leafy greens, particularly those found in arugula, Swiss chard, and dark lettuces, activate cellular pathways that protect mitochondrial membranes, enhance mitochondrial biogenesis, the creation of new mitochondria, and improve the efficiency of the electron transport chain. When your mitochondria are working well, your cells are working well. When your cells are working well, your tissues are working well. It flows all the way up from the organelle to the organ. There's also the matter of nitrates, not the processed nitrates in cured meats. Those are a different story entirely. The naturally occurring dietary nitrates in leafy greens, especially in arugula, spinach, and Swiss chard, follow a completely different pathway. In the presence of bacteria on the tongue and in the gut, these nitrates convert to nitrites and then to nitric oxide, a signaling molecule that relaxes and dilates blood vessels, reduces blood pressure, improves oxygen delivery to tissues, and enhances mitochondrial efficiency. Athletes now use concentrated beet and leafy green extracts to improve endurance performance for exactly this reason. But the cardiovascular protection runs deeper. Nitric oxide also inhibits platelet aggregation, reducing clotting risk, and suppresses the adhesion of inflammatory cells to vessel walls, slowing the progression of atherosclerosis. The leaf is cardiovascular medicine. It always has been. There's another dimension here that is rarely discussed, and it connects leafy greens to brain health in a way that should change how we think about cognitive decline. The brain is extraordinarily vulnerable to oxidative stress and inflammation. It consumes a disproportionate share of the body's oxygen, about 20% of total oxygen intake despite being only 2% of body weight, and that intense metabolic activity generates enormous amounts of reactive oxygen species. Without sufficient antioxidant protection, neural tissue degrades, synaptic connections weaken, cognitive speed slows. The compounds in leafy greens, particularly lutein, zeaxanthin, folate, and vitamin K, accumulate specifically in neural tissue and have been associated in longitudinal studies with slower rates of cognitive decline. Lutein and azeaxanthin, most abundant in kale, spinach, and collard greens, cross the blood-brain barrier and concentrate in the regions of the brain responsible for executive function and memory consolidation. Folate drives the methylation cycle, which regulates neurotransmitter production and DNA repair in neurons. Vitamin K activates proteins that protect myelin, the insulating sheath around nerve fibers. The leafy green is not just keeping the body alive, it is keeping the mind sharp. Now, practical application. Because all of this knowledge becomes worthless if it does not change what you do tomorrow morning. The goal is not to eat a salad once a week and check the box. The goal is to create consistent daily signal delivery to every system described above. That means eating leafy greens every single day and rotating through varieties, because different greens activate different pathways. Spinach for thylakoids and magnesium, kale for sulforaphane and NRF2 activation, arugula for nitrates and cardiovascular protection, Swiss chard for mitochondrial polyphenols and betalains, romaine and butterhead lettuce for lutein and zeaxanthin, which protect the eyes and the brain, dark watercress for its exceptional glucosinolate density, arguably higher than any other leafy green studied. Rotation is not variety for pleasure. Rotation is ensuring that all pathways receive their signals, and preparation matters as much as selection. Raw or lightly cooked for cruciferous varieties to preserve myrosinase activity, massaged raw kale dressed with acid and fat. The acid brightens, the fat carries the fat-soluble nutrients like vitamins K and E into absorption. Cooking spinach actually increases the bioavailability of certain compounds by breaking down oxalates that otherwise bind minerals. Wilting arugula briefly in a hot pan preserves its nitrates while reducing some of its bitterness. The science of preparation is the science of bioavailability. How you treat the leaf determines how much of its intelligence actually reaches your cells. The body was designed to receive these signals. For the vast majority of human history, wild leafy plants were eaten daily in quantity and diversity. The chronic inflammatory diseases that now dominate modern medicine, cardiovascular disease, type 2 diabetes, Alzheimer's, autoimmune conditions, most cancers, were dramatically rarer not only because of other lifestyle factors, but because the biochemical input from leafy plants was constant, diverse, and unprocessed. We did not evolve eating capsules. We evolved eating leaves. And when the leaves stop coming, the body begins a slow process of signal deprivation that looks, over decades, exactly like the disease patterns we now call aging. I have eaten dark leafy greens every single day for as long as I can remember. Not because someone told me they were healthy, because they are information, because inside every dark leaf is a compressed archive of biological instructions, written in the language of photosynthesis and phenolic chemistry, addressed directly to the immune system, the gut, the mitochondria, and the genome. Every cell in this body has been receiving those instructions for over a century, and every cell is listening. Do not underestimate what grows close to the ground.